So what I've done, I have the Canvas slides, this link organized by topic or by chapter. So we start with kinetics, lecture slides on this link, and then equilibrium, we made that through. So here's some video lectures from previous semesters. So if you want to catch up on that, you can. And then chapter 16. So this is all information from chapter 16. And you guys can see my Canvas screen, right?
Yes.
Okay. So video lecture number 1, then I started numbering them. So VL number 1, just because I'm going to have a lot of video lectures and I want to be able to clearly tell you which one to watch. So chapter 16. So this is one I made last week. It was like a 10-minute video to watch because I missed that Monday. And then in lecture, last week, Wednesday, I recorded that in 3 segments and posted it here because some students were absent and I was practicing having an online class. And then I have 3 more video lectures. So video lecture 5, 6, 7. And what I do, I try to be specific in the title of the link as to the topics are going to be covered. So because I have lecture or practice exercises embedded in my lecture slides, that makes it a little bit easier for you guys to know what that's covering. And then I also have a description and I write down how many minutes it is. So you kind of know what you're getting into. So these are the different video lectures. And one thing I stated this up at the top, but some of these video lectures are from about 2 years ago when we used an older edition of the textbook and the chapters had different numbers. So I might be talking about chapter 15, but that's just the older edition of the text. So I hope that doesn't really throw anyone off.
Yeah, videos have been extremely helpful. It feels like you're just in class going over it. So I really liked it so far.
Okay, cool. Have you had a chance to watch any of these, Nicholas?
No.
Okay.
No,
So that my goal is for you guys to get through the segment that we basically started face to face before we meet back online on the 30th. So really the main new topic is getting the pH of a weak base. And that's what's due. I made that due on Friday on Alex. And so that's this video lecture number 7. So practice exercise 13, calculating the pH of a weak base. So I walk you through how to do that, and then you'll have some Alex problems on it. And so Nicholas, I would encourage you to find time to ideally the next couple of days to get this done. At a minimum, just watching video lecture number 7, even at just the end, and that will help you with your Alex assignment. And then what I did, whenever you finish that last Alex assignment that's due Friday, there's a knowledge check. So a review of everything we've done. And then there's Open Pie scheduled. So you'll have then what's our new spring break week, and we're all going to probably be kind of locked inside anyways, working on reviewing the Alex topics that we've gone over so far. And then when we come back from spring break, we'll jump into finishing up chapter 16 and then starting chapter 17. Yeah, Nicholas.
which is the topic that's due Friday? Because the last I looked at my Alex, I was caught up with everything, but now it's just locked out until I do my knowledge check.
Then you're probably caught up. So can you see my Alex screen now?
Yeah. Yes.
And I have a very different view than you do on Alex, I believe.
Yeah.
Yeah. So the way that, so do you want me to look at your specific assignment to make sure you're caught up, Nicholas?
If it doesn't take too long, I don't want to waste everyone else's time. But I mainly just wanted to know.
So let me show you. So yeah, let me show you the topic that's due.
My biggest problem is always figuring out what to do next. Like
and that's why
somebody just tell me, here, study this. Exactly.
And that was my goal. So I'll hop here. So let me, 2 things. So what's due on Friday? There's got to be a better way for me to see this, but I don't know. So what's due on Friday? And what I can do, I'll take a screenshot and post this on Facebook. This is what's due on Friday. This is what was due.
Oh, each one doesn't have that many topics, right?
No.
Okay, because mine finished too, but I did it, I think, like last week.
So you were working ahead then.
Okay.
So this is what is due.
Yeah, I'm done with that.
So I forgot. This is something that I sometimes would take screenshots and post in our Facebook group so that you guys know. And this, again, this is why I like Facebook. This is a lot faster than trying to upload an image onto Canvas because I don't have to save it or anything. Okay, so that's what's due on Friday, calculating the pH of a weak base solution. And to give you an idea of what that is, just to make sure you can double check that you've done this already. So I can double click and see a practice problem. So the base protonation constant KB. So have you seen something like that, KB, Nicholas?
Oh, yeah. Yeah,
Okay, yeah. So then you're caught up. So then on Alex, you'll be working on a knowledge check, and then you'll have open pi. So you can go back and redo any of the previous topics for practice.
That's what I'm hoping to do, and I know the knowledge check will, give me an assessment on what I need to cover.
Yeah.
But if you were to make a list of which topics are the most important to review for the next exam, which topics would you focus on?
Everything. There's not, and we haven't had that much. So we've only had.
But not everything going all the way back to like the prior exam.
No, everything post exam 1. So
which would be starting with what?
So if you think about exam 1 covered kinetics, so don't focus on that right now, but you can if you want to. And then equilibrium. And equilibrium, pretty much all that we learned from equilibrium that was on exam 1, at least what comes to my mind, how to write down a K expression, which at this point you should be experts with because of chapter 16. And the really simple ice boxes, and the X approximation. And all of those topics, you now know really well because you've made it through chapter 16. And then the other new topic from chapter 15 that is really a standalone is Le Chatelier's principle that we talked about a little bit at the start of our office hours today.
Okay, so you said equilibrium, which is the K expressions. And I didn't write it down.
Yeah, let's make a note of this.
You mentioned 3 things.
Items to review during open pi on Alex. So we have 1, chapter 15, writing K for heterogeneous. Oh, that was exam 1, sorry. Chapter 15, Le Chatelier's principle. No. Or ice with the K approximation. 2, chapter 15, Le Chatelier's. And then 3, really all of chapter 16.
Hi, Doctor. How are you?
Alex?
1 second. Foundation of chapter 17. Hi, is this Susie?
Hi, yes, it is.
Hi, how are you?
Good, thank you. I just had like two questions, but
okay, great.
I can wait if Nick has any more
Okay,
questions.
so yeah, let me finish up with Nick's specific questions,
Sure.
then I'll go on to your question, Susie.
Sure.
So Nick, does that help you out?
Yeah, definitely. Thank you.
Okay, cool. Susie, what's your question?
I've been getting a little bit not confused, but I don't really know when to use the formula, like the KW formula.
Okay, let me go ahead and sorry.
It's okay.
I'm trying to turn this off. How do I just have faculty text me about everything right now. Oh, I did. So I turn off message, but they still show up. Okay. So you have questions about the K equations?
Yeah, so whenever I'm looking at an explanation on Alex and that formula is included, it doesn't make complete sense, as in it wouldn't really come to mind to use that equation. So yeah, I think I'm just not connecting the dots.
Do you have a specific problem that I could help you work on? Because sometimes that's helpful.
I think she's talking about the same one you and I went over last time where they were using that 1.01.
Yeah, so I think, do you want me to, so I can make up a problem or
Sure.
do you have one that you have written down and you can read it to me and we can work on it?
I don't. I'm sorry. Yeah, I was just on Alex and I realized that I need to know that better.
Okay, so let's look at an example problem that I'll just make up right now.
Okay.
So and I'm just going to use shorthand notes. So if our pH equals 5.28, find my OH minus molarity. Okay?
Mm-hmm.
So there's 2 ways.
Mm-hmm.
And let's do both of them, okay?
Okay.
Some of them we found work better for Alex, as Nicholas knows. For an exam, they're both going to be good. So I think what we're going to need to do, and I don't remember getting that many, I don't remember getting any of these questions last semester. So I'm hoping this is the only time it's going to be a problem with that one specific type of question that we're looking at together, Nicholas. So 2 ways. The first thing I can do is use my equation. pH plus POH equals 14.00. And then 2, I can use, once I get a POH, I know that hydroxide equals 10 to the negative POH. And the equations that I'm thinking of, I'm going to just hop to the study guide real fast. Are these. Right, so you should have that one out and this one out. So I, because I teach this class, I've got all these memorized. Have these out when you're doing the problems. So, questions so far, and I'm not done. I'll go over more.
Even though, I have access to those formulas, I don't really know like when to use it.
And that's going to be just from lots and lots of practice.
Okay.
And so realize once you work through your Alex objectives, a good place to get practice is going to be from my practice exams online. That would be another good place to look.
Okay.
So,
sorry, go ahead.
No, what were you going to say?
I was just going to ask, is there like a word in the problem that, or something that's given that should, trigger me to use that?
pH, find OH minus.
Okay.
So method number 1, and we'll do both of these together. Method number 2.
Okay.
So yeah, it's kind of like algebra. Like, how do you know what to do? It's from lots and lots of practice.
Okay.
So how do you know which equation to use? It's for the more practice you do, the more comfortable you are with these equations. And a lot of it, I think I wrote in your study guide with you in office hours or workshop, like what's given and what you're trying to find. Did we go over that?
That was helpful.
So using that also.
Okay.
So method number 2, I can say step 1, I know hydronium, because I'm trying to find that, is 10 to the negative pH. So I'm going to always use an equation where the given is on this side. And so here I'm given. And we'll go over that together. And then step 2, once I get hydronium, I know that Kw equals hydronium times hydroxide. And so hydroxide is Kw over hydronium. So those are the 2 different directions we can go to, in theory, get the same final answer.
Okay, so on the left, we went from So
let's try this. Let's go over the math together and then see how that works. So for method number 1, step 1, I want to find a POH. So my POH is just going to be the 14.00 minus my pH. And instead of pH, what should I write down?
Sorry, it's just so noisy outside. So you should.
Do you have headphones?
Not
sometimes that makes it easier.
Not right now. Not
okay.
accessible.
So keep that in mind because we're probably going to be doing this a lot. I found that if I put my headphones in, it's a lot easier for me to hear what's going on if I'm in either a crowded room or.
Yeah, no, I can hear it. Just I don't want the noise to like bother anyone else if I'm not on mute.
Yeah, no, it's not that bad.
Okay.
Okay, so POH equals 14 minus, instead of pH, what should we write down? What number?
We should write 5.28.
Yeah. So now do you have your calculator on you?
No.
Oh, Susie, have a calculator next time, okay?
Sorry.
So that's okay.
This is my first office hour.
Oh yeah,
online, so now I know what to
I'm
do.
happy you're here. So I'm just giving you suggestions. I'm not at all criticizing.
Thank you.
14 minus 5.28, I got 8.72. And then Eileen or Nicholas, do you have a calculator?
Yes.
I want you to confirm what I'm doing because as you know, I make mistakes.
Yeah, I actually solved for it too. So.
Okay, cool. So pOH is 8.72. If anything I do you get differently, let me know.
That's right.
So that's subtraction. And now that I have a pOH, that is what I have, right? Given this is what I have. So I can find hydroxide, 10 to the negative 8.72. So my hydroxide molarity, 10 exponent, and now I can just do negative second function answer, and it pulls down the number I had up. And now I got 0.0, there's a whole bunch of zeros and a 2.
Yeah.
There's probably more sig figs than that. It's just hiding. So I switch into scientific notation, and I find 1.905 times 10 to the negative 9th molarity. And then sig figs, so I have 2 digits past the decimal. So I want 2 sig figs. So I believe that would be 1.9 times 10 to the negative 9th molar.
And then
that though from the calculator, because mine only gives the 0.00.
Yeah, so let's go over that. What I'm going to do, I'm going to see if I stop sharing the screen. And so what do you see right now? What do you guys all see right now? Do you all see Eileen?
No, I see you.
Now I see you. Okay, so I think if I start talking, okay, there we go. So on my calculator, can you see this? Oh gosh,
No.
I don't know how to get rid of this glare. I need to be in like in a dark room.
Yeah.
Hold on. Okay, so I had 10, I have to get this back up, 10 to the negative 8.72. Okay, so and I think if I figure out how to angle this properly, can you see that?
No, I don't know why I'm saying that doesn't help.
There's got to be.
I think there's a glare.
Okay, so anyways, my calculator says 0.00002.
Yeah, that's what.
And that's because it's in decimal form, and calculators are lazy. If they can give you a numerical value with just one answer, it will. Does that work? No.
Oh, yes.
Okay, so what I'm going to do, can you see that, Nicholas?
Yeah,
No, I see
that's
his picture, but
Okay, so that,
yeah.
the calculator's like, I'm giving you a number, but it's hiding all the sig figs.
Right.
So what I have to do is convert it into scientific notation.
Right.
So to do that on my calculator, I go second psi right here, or second that degree, and I have to go into scientific notation and then press enter. And now I can see it's backwards for you guys, but now I can see that's actually that number. So every calculator is different. You need to make sure that you learn on yours how to go back and forth.
So after we've taken it to the scientific notation form, do we convert it back to flow or normal?
Well, whatever you want. So I tend to like to leave my calculator in flow because if I see the number 10, I want to see 10, not 1 times 10 to the first.
Okay.
So, but I know how to go back and forth quickly. So then I can just go second psi, and I can go back to flow, enter, and we get there.
Okay.
So it's important to be able to go back and forth.
Okay.
Did you guys all see that?
Yes. How do you go back?
Okay, and then let me see what was beeping. I don't know why my computer was talking to me.
Yeah, that's interesting. Okay.
So that's really important.
So for the exam, if we had put 2.00 times 10 to the negative 9, is that wrong?
It would have been wrong.
It would have been wrong. Okay.
Yeah. I mean, it'd be like -1 or -0.5 point or something like that. Although our exams are going to be online. So you'd probably, I wouldn't give you, so our exams in the future are going to be online because we're not going to be able to meet face-to-face. So if I was making a multiple choice question, I would not have an answer 1.9 times 10 to the negative 9th or 2.0 times 10 to the negative. That's just mean.
Okay.
So, but you need to be able to recognize that your answer on your calculator is actually 1.9 times 10 to the negative 9th. Nicholas and then Susie. Yeah.
I want to make sure Susie doesn't get stuck the same way I did on that problem. But Susie, are you talking about the problem that says a chemist must prepare 750 milliliters of potassium hydroxide solution with a pH of 13.9, and he will do this in 3 steps, and then it tells you the steps? Is it that kind of a problem?
I don't think it was exactly that one. I just think in general, I didn't have I just wanted to make sure
basic equations, right?
Yeah.
My understanding of when to use it was, solid.
I think you're in the same section that I got stuck on, because if you remember, Professor Harvey, there was a problem where
Yeah,
To do the
last
POH
office hours.
calculation, you can't use 14.
Yeah.
You actually had to use negative log of 1.01 times 10 to the negative 14th, which
So what I want to
throws it
do,
off by like,
so Nicholas, I'm worried that you're going to confuse Susie right now.
Oh,
Let's go over
no.
method 2, and I think
it'll
that's what
reject
you're.
her. It'll reject her answers because it was rejecting mine forever. That's why I had to get help from you the last time.
Yeah. So I think method 2 is what you're saying out loud. So I want to write down method 2, and then you can give us some insight onto that.
Method 1 works. The problem is that 14 will just be off by a tiny fraction. That's all.
So we need to use the 13.998
Yeah, it was something like that. But the easiest way to be the most accurate is just
method 2, right?
like you showed me the negative log of the
Okay.
1.01 they use.
Give me 1 second. Let's walk through method 2 and see if that works. Hey, Sabrina, how are you?
Hi.
Good to see you. Okay, so right now
I'm
we're just
good. How
going
are
over
you?
a practice problem. I'm good,
Well, it's
thank you.
good to see you too. Thank you.
It's weird being remote, huh?
Yeah,
So have you, just real quick, have any of you guys taken online classes before?
No.
not something like chemistry.
Because
Yeah,
most
Yeah,
colleges don't
it
accept
is.
online classes. So
So I guess, and well, now I guess you're taking all of your classes
Yeah.
online. So what I want you to do, things that you experience in your online classes that are good, share them with me, because I am DE certified, so I've taken classes on how to be an online teacher. So technically I went through all of that, but it's not the same as actually doing it. So be open with your instructors to give them feedback, because we're all in this together to figure out the best way to work through this. Okay, so method 2, H plus. So again, a second way to do the same problem, 10 to the negative pH. Okay, so now on my calculator, and correct me if I'm wrong, 10 to the exponent negative 5.28, enter. And again, I got in decimal form. I'm going to go into scientific notation so it's easier to write. I don't have to count all those zeros. So 5.248 times 10 to the negative 6. And that would be a molarity. Questions on that?
No.
And then the second way, I'm going to use my KW expression. So hydroxide equals KW, and this is 1.01 times 10 to the negative 14th for Alex, is that correct?
Yeah.
Okay. Divided by my H plus 5.24807 times 10 to the negative 6. So on the calculator, all I have to do is I type in 1.01 second E negative 14 divided by second function answer. And I got 1.9245 times 10 to the negative 9th. So here, 2 digits past the decimal for sig figs. Gives me 2 sig figs here, 2 sig figs here, gives me 2 sig figs here. So the answer would indeed be 1.9 times 10 to the negative 9th molar. So, yes.
Dr. Harvey, with the sig figs, I just get a little bit confused. I know that it's like sometimes the sig figs are the number of digits after the decimal, or is it like the other way around?
So let's go ahead and look at the study guide. So here are some notes on sig figs. So we're going to read them over and do some examples. So let's first look at this equation here. 2 sig figs in the H plus molarity. So that means if I have 2 sig figs here, I need to have 2 digits past the decimal for the pH. That means I end up with 2 digits past decimal. So for example, my H plus molarity, let's do 3 sig figs, okay? And let's just keep it simple with 2. If I have 1.5 times 10 to the negative 6th molar, what is my pH going to be? How do I find that? What equation am I going to use? Yeah, Susie, what were you saying?
No, sorry, I let Nick answer.
Okay.
Negative log.
Yeah, so negative log of 1.5 times 10 to the negative 6th, and that gives me a pH of what? So negative log 1.5 second E negative 6. I'm going to go back to flow because it's easier for me to read. And I got 5.8239. Now with our, so
yeah.
what would that be with sig figs?
So it would be 5.82.
Wonderful.
Because it says
2 sig fig wouldn't be 5.8.
So remember, it's 2 sig figs in the molarity. I need 2 sig figs past the decimal, or 2 digits past the decimal. Do you see that?
Yeah, I never understood why that's the rule.
It's some algebra teacher taught us at some point. I don't know. I'm following the rule. I've got enough things to explain. We don't need to focus on that.
So it's
we
like
know
the
why.
opposite.
We know when to do that. Yeah.
You use that anytime you're using logs, a logarithm.
Logs.
Okay.
So these are our rules for logs. And when do we have logs? I have a log here or a 10 to the. A log here or a 10 to the. So those sig fig rules are going to work all the time. And also here, a log and 10 to the. Log, 10 to the. So anytime you're using one of those two equations, that's when you use your significant figure rules.
Okay.
Do you want to try a practice one with another equation?
It's
Are you
okay, Dr.
okay?
Harvey. Yeah, it's okay. I could honestly practice with Alex. I just wanted to clarify these things.
Good. Who has, I don't remember, was there anyone else online or who has another question? And another thing you guys can do, so in your Zoom meeting, do you have a list of participants?
Yeah.
So, and you see on the bottom, click on more, and like I can wave, or I guess it's a clap, and then I can do like thumbs down, thumbs up, and need a coffee break. So if you want to, you can raise your hand if you've got a question, and I'm starting to learn to look at that. You know what I mean? And then I can hit clear all if I end up if I've answered a bunch of questions. So I think you can put your question, your hand, you can probably put your own hand down after I get your question. So just kind of ways that we can learn to communicate in this online environment. Eileen, do you have a question?
Yes.
Okay. And it's cool. So I see your hand also by your face in your image.
Oh, okay.
And then I can lower your hand because I'm talking to you now. Okay, so what can I help you with?
So I had just 2 general questions. One of them is quick. For practice exercise 9, I get how to do it. I don't know if you need to look at it, but the answer was 2.7% for the ionization.
Oh, goodness, sorry. So wait, I'm going to go to the lecture slides because that'll probably be more informative. To practice exercise 9.
Yes. So I completely understand how to do it. You just mentioned after we got the answer that this means that we have mostly reactants, not many products.
Okay.
What does that have to do with so if the ionization percent is low?
Yeah, so what does a percent ionization mean?
So the amount of dissociation.
Yeah, well, the amount of dissociation, and also dissociation, those are your products, right?
Oh, right.
So if you have a low dissociation, you have a low
Amount of products.
So a low which also means if you have a small amount of products, you also have a small Ka value.
Okay, that makes sense.
And if anyone wants to see me do this problem, I'm happy to.
Can we?
Yeah.
Dr. Harvey?
So the first thing we need to remember, and I think this is something that I have you memorize, is your percent ionization. So percent ionization equals your hydronium at equilibrium over HA initial times 100. And this is for an acid. If I had a base, what do bases ionize into? Do the bases form hydronium?
No.
So base percent ionization equals so what do we make? We don't make hydronium. What do we make it for a base?
OH.
Yeah, hydroxide. So it's hydroxide at equilibrium over my base molarity initial, and then again times 100 to make it a percent.
Okay.
So now, Susie, this is another example of like how to know what equation to use.
Right.
So for this equation, I know I already have this, right?
Yes.
That's my initial molarity of the acid. I need to find this. So because I'm looking at my equation sheet, or I'm really familiar with those equations, I know I can get my hydronium by looking at 10 to the negative pH. So my hydronium, and realize this is always at equilibrium because I put an acid into water and I let the reaction go. So I let it dissociate. So 10 to the negative pH, 10 to the negative 3.26. So my hydronium at equilibrium equals, now on the calculator, 10 to the negative 3.26. And so that's 5.495 times 10 to the negative 1, 2, 3, 4. So so if I was just looking for hydronium, sig figs, what do I think about? Susie, what do you think?
If you're just looking for hydronium.
If this was my final answer and I need my answer with the right number of sig figs, what would I be thinking about?
I think you would do
So this
2
is,
sig figs.
yes, so 2 digits past the decimal. I need 2 sig figs here, but I want to round at the end. So this is the first thing I did. Yeah, what was that?
Your final answer?
Yeah, so I'm not done yet because remember my final answer is to get this, my percent ionization.
And then you only round the
round
final
at the
answer.
end. So now I can get my percent ionization. 5.495 times 10 to the negative 4th over HA initial 0.020 times 100. So now on the calculator, so remember I have this, I mean you can't really see it, but that number is in my calculator right now. So all I have to type in is divided by 0.02, so it pulls up the answer that I just had times 100. And that way you're not rounding it at all because you're leaving that entire number in your calculator.
Yeah,
and now
I try to do that as much as possible.
Yeah, awesome. And I know I had 2 sig figs here. I have 2 here. So my answer needs 2 sig figs because now we're back just to our rules for division.
2.7.
Yeah. Did anybody else get that?
Yeah.
Awesome.
So we have to memorize that formula, the percent ionization of an acid.
Yeah, and I mean, I'm probably going to make, what I'll do for our exams, I'll make an equation sheet that I'll have you guys print out or have visible. Okay. So you know what to look at. And since I won't be there with you.
Dr. Harvey, I wanted to ask you about, like, in terms of showing work, I know that sometimes if we get the wrong answer, but you know, the work is there.
It's going to be most likely a different testing environment. So on the paper exams, I like to have complex problems because I think it tests kind of like a higher level of thinking. You know, you do a couple steps together. And then I think, to be fair, if you make a mistake in the first part, but do everything else right, I still give you partial credit. So and again, I don't know yet because I haven't figured out how to do the exams. I haven't gotten there yet in my planning. But what I'm anticipating right now is that you'll probably just have more questions that are like one-step problems.
Oh, okay.
So, because there won't be an easy way for me to give partial credit. And then maybe you'll have one question that's a little bit longer, multi-step question. And I'll see. Maybe there is a way that I can grade some questions still that are written out, but I don't know.
Okay. Just wondering. Thank you.
Yeah, you're welcome. Eileen, did you have a question?
Oh, yeah, I had one last question. It was regarding an Alex problem.
Okay.
I can't pull it up because I need to do the next knowledge check.
Let
but
me see if I can pull it up.
yeah, it was regarding identifying strong or weak acids from sketches.
Okay. So that's like something we need to see. I'm gonna pull up now my Google Chrome screen. Can you guys see my Alex account? So
Yes.
do you know which topic it was?
It was called identifying strong or weak acids and bases from sketches. It would like show.
Yeah, let's just see. Identifying, this is it.
Yeah.
Okay, and you can see the screen still?
Yes.
Okay, so the key here, identifying a strong or weak acid from a sketch. So I'm gonna go back to my iPad real fast. To think about strong and weak acids, and then let's go back to Alex and talk about that. So what do I know about a strong acid?
So it completely dissociates.
So if I have, hold on, I'm gonna see what they're, okay, cool. So if I have HCl, aqueous, in a beaker, what is actually there? So let's think about our equation. HCl, aqueous, plus H2O, full arrow, and I end up with hydronium and chloride. Yeah?
Mm-hmm.
So what would be, if I had microscopic eyes, what would be in my beaker? What could I see?
So you could see hydronium,
H3O plus.
Chloride, Cl minus, and water.
Yeah. So let's look at these terms of like kind of on the particle scale. So I would have a water. I would have a hydronium. Let's go red. And I would have my anion, chloride. Is chloride basic?
Yes.
No.
No? Okay.
So remember, Cl minus is not basic because the conjugate base
that's right.
of a strong acid is not basic.
Okay.
So it just hangs out in water and chills as chloride. It's happy and stable as Cl minus. So if it's not basic, that means it's not reactive.
Okay.
If something is basic, that means it's reactive. Questions on the strong acid sketch? Okay, now let's look at a weak acid. So a weak acid dissociates what? Much.
The equilibrium?
Yeah.
Ka.
Less than 100%, so we have equilibrium. So let's look at the specific weak acid, HF. Because it's a binary acid, but it's our one weak acid. And the reason for that is because fluoride on the periodic table, it's really small. It's the first halogen. So it has fluoride F minus is really, really small. H plus is really, really small. So if you have two small atoms, when they because remember we make bonds by overlapping orbitals. So when those orbitals overlap, they have a really effective overlap because both those atoms are small and they have similar energy. So that makes a pretty strong bond.
Okay.
So if that is a really strong bond, it doesn't completely dissociate. You go down one halogen, I think what's below fluoride, chloride, now that is a much larger atom. The overlap with H plus isn't nearly as effective. You put it into water, it completely dissociates.
Okay.
So that's why HF is a weak acid and HCl, et cetera, are not. So we have our equilibrium. And I'm going to make, again, hydronium and fluoride. So now, if I put, let me keep this in the same image. So if I put HF, aqueous, into my beaker, what am I going to see?
So hydronium, fluoride, and water.
Yeah, hydronium, fluoride, water, and what else?
And HF.
And HF. That's the key.
Oh, okay.
So I'm going to have, just to color code these again, my hydronium particle, right, ion, molecule, my water, my completely together acid, and then my Cl minus, and what, I'm sorry, my F minus, and what do I know about F minus?
It's not basic.
Is basic.
It's basic. So for a weak acid, you're.
Yeah.
Yeah, so the conjugate base of a weak acid is basic.
Okay, I have to remember this. Okay.
Yeah, so these are conjugate base of a strong acid is not basic. Conjugate base of a weak acid is basic.
Okay.
And what does that mean? If I put fluoride into water, what's it going to do? Well, it's basic, so it's going to react with water to form hydroxide. So let's look at this together. So if I put fluoride into water, because this is basic, it reacts with water. And now my base equation, which you really just saw in those video lectures, and I guess we talked about it a little bit in the start, I think, a base accepts a proton. So it grabs a proton from water to form HF and hydroxide.
Mm-hmm.
Chloride is not basic. So if I put chloride into water, what happens?
Comes HCl or
No reaction.
Okay.
So a base is something that reacts with water to form, right? So if this is my base, conjugate acid, conjugate base. So a base is something that reacts with water to produce its conjugate acid and then hydroxide.
Mm-hmm.
How do you know that F minus is basic? Because you know HF is a weak acid, therefore its conjugate base is a weak base.
Okay. Okay. That makes
So
sense.
these are the topics that we need to understand to answer the Alex problem.
Okay. I think that was the problem then.
Any questions on these topics? And then I'm going to switch back to my Alex screen and go over one of these. We're good?
Mm-hmm.
Okay, so let's see. I'm going to share my Google Chrome. So what I did, so what this problem is, and I don't think I can't move the sketches, but we talked about the answers here. So a strong acid, why is this a strong acid? Because a strong acid, you have hydronium, and you have, do they tell us what these blue dots are? Hydronium and the conjugate base. So I think it says ignore water.
Oh, yeah. Okay.
So I believe it told us to ignore water in these sketches. Or no, we've got water. Oh no, I just can't see it because I'm not looking carefully. So if I can see, what am I circling right now with my mouse? That's water.
Oh, okay, okay.
And right here, that's just a single particle. So that would be like the conjugate, that's Cl minus.
Okay.
And this is hydronium. So what I would do, I would write down, I've got hydronium, I've got H2O, and I've got one particle. And so that one particle could be my conjugate base.
Okay.
And chloride. Why is this not, so I know this is an acid because I've got hydronium, H3O+.
Mm-hmm.
I know it's a strong acid because the HA in this case would have been a white dot and a blue dot together. That would have been the acid connected, like my HCl.
Oh,
because
right.
there's no white dot and blue dot together, it's strong.
Okay.
I know this is basic because I see a white and a red dot, that's hydroxide.
Oh, okay.
I know it's a strong base because all of my blue dots are by themselves.
Okay. That makes sense.
Let's look at another, because I think we're going to have a couple different examples. So strong acid versus weak acid. I know this is an acid because I've got H3O+.
Mm-hmm.
I know it's strong because all the blue dots are by themselves.
Right.
I know this is an acid on the right because I've got H3O+. I know it's a weak acid because I've got some blue dots, which are the conjugate base. I also have some white blue, which is my HA connected. So in the example I gave, that would have been HF and F minus. This would have been Cl minus and hydronium.
That makes sense. Okay.
let's look at another one and try and get a weak base example. So again, weak acid, we talked about hydronium, conjugate base, HA together. This is a weak base. I know it's basic because I have the OH minus right there. And then I can see I've got some of the base by itself, and then the protonated base, the BH plus or whatever it would be.
Okay.
Did that help?
That was very helpful. Thank you.
Good. You're welcome. I think we have time for one more question if anyone has any. Any questions at the moment? So just quick recap. Hopefully you're all in our Facebook group. So what I've done on Facebook, and I'll try to remember to do this because I think it's helpful, posting my view, what topics, and the due dates and time, so you know what's up for that week. And then I also posted things to think about over the next week and a half before we formally start our online classes again. And I posted, this was in Canvas, and I also posted it here, some notes about our exam schedule, lab, office hours. Thank you for attending today. And then numbers 1 through 6 and what to work on between now and March 30th. Yeah, Susie, did you have a question?
Yeah, Dr. Harvey, did you say that's on Canvas or Facebook?
Both. So
Both.
I posted
Okay.
this announcement. So this is Facebook. And so things that you're going to see on Facebook that you won't see on Canvas, like informal announcements, things that are helpful but not mandatory, like this post about Alex. On Canvas, again, chapter 16, all of my video lectures are here. Khan Academy videos are just, it's another resource of a helpful thing to watch. And this again is under lecture slides and video links. And I tried to make it clear, you know, for this semester, we'll have a lot of online classes and lectures. And then the other, so this is under modules or the home tab, they both go to modules. The other thing that's useful on Canvas, announcements. And if you have it set up, when I post an announcement, it emails you. So make sure your Canvas settings are correct. And so on Canvas, all of these links, you can click it and it actually takes you to the video, I believe.
Okay. Okay, so this recorded office hours will be on Canvas?
So yeah, I recorded this office hour. So what I'm probably going to do, I think I made a tab, office hour PDF notes.
Yeah,
Assuming I properly recorded this lecture and I can download it, I'll add a link. So I'll upload my PDF notes from today's office hours, and I'll upload a link to the Zoom video, assuming I can figure that out.
Thank you so much, Dr. Harvey.
You're welcome.
For online labs, there will be some information on Canvas.
Yeah, so we'll talk about online labs once we start class again March 30th, because I'll have a definite answer for you about exactly how those will work.
Okay, thank you.
Yeah, Nicholas.
Did you happen to figure out how to let us just hit that record button so I can just record it and have it on my computer instead of digging it up in Canvas?
I don't know, but next time we do one of these office hours, but remind me, and when I start the office hours, I'll figure out what button to push, and then you can tell me if it works because you'll be able to record it.
Okay.
So yeah, remind me at the start. I'm happy to do that.
I actually had another question, but somebody else go ahead while I look for the photo that references it.
Well, it's a little after 10, so I need to get going. So if it's a quick question, I'm happy to answer it.
I sent it to you in your email too, so if you have time to check that email and just reply, you can go ahead.
Can you post it on the Facebook page and I can reply that way?
Okay.
So questions about homework problems, I prefer to answer via Facebook, because by putting it on Facebook, then all 64 students are going to benefit from that, or everyone who's in the class. And oftentimes you guys can then start answering each other's questions and helping each other out. So it's just a way for you to get help more quickly if I'm not right there. And right now with everything going, trying to figure out how to make everything online, I'm going to be a little bit less responsive than March 30th when I'm back full-time in the classes. So do try to use that Facebook group too, okay?
Thank you so much for your help.
Okay, thank you very much. And I'm going
Harvey.
to figure out how to stop recording and get this on Canvas. I've been told the download from Zoom, or to get it ready to post the link, it takes a few hours because they're so swamped right now.
Oh,
but I'll get the PDF notes right now, okay?
Awesome.
okay, thank you, Dr.
Okay,
Harvey.
good luck with
Bye.
everything. Bye.
Have a nice day.
You too.